In this video, we're going to go through and talk about linear regression. And so as we've seen in previous videos, when we've worked with linear expressions represented in tables, we've been able to use the table to find the slope and a y-intercept and the right-hand equation of a line. Well, not every single problem can be represented exactly by taking and finding the slope and the y-intercept and writing it in y equals mx plus b form. In fact, a lot of times, especially with statistics, what happens is you get a lot of data that resembles a line, but it doesn't make a perfect line. And so what we do is we try to make a line of best fit, which will try to get as close as it can to the most number of points in that spread there to represent the data. And that process is called regression. And there's all kinds of regression that you'll learn down the road that's not just linear. We have quadratic, exponential, cubic, and a bunch of others. So we're going to use Desmos to do this since we have access to Desmos on our test and our final exam. You can do this on the TI-84, but for right now, in context of making this video, I'm going to assume you don't have access to a TI-84. And the way we would do it is we have to type in the table in the Desmos, and then we have to type in this equation exactly the way it shows up, even with the subscript numbers. And Desmos does all the heavy lifting for us and will give us all the parameters, so it'll tell us what M is and tell us what B is. And it does a lot of the work for us. So let's go through the process here. So we want to perform the linear regression for this first table, which represents a math teacher that wanted to see the correlation between test scores and homework. The homework grade was X, the test grade was Y, and it says write the linear regression equation that represents the set of this data. Now they want us to round all the coefficients to the nearest 100th. So I'm going to open up Desmos. It'll look a little bit different on your computer, but in terms of how you would get there, you go to desmos.com, desmos.com. And what we're going to do is we're going to create a table. So to make a table, you touch the plus sign and then table. And it pre-makes an X column and a Y column. And we're going to type all these numbers in. So I got 83. Okay, so everything is typed in into the table. Now, if you want to see these points graphed, you're going to see the little magnifying glass in the bottom left of this block you're typing in. And if you touch that magnifying glass, it'll put all of the points on the graph for you. And we can kind of zoom out as we needed to see what it is we have here. Now, if your zoom window is pretty bad, you're not going to be able to tell that these points actually resemble a line or not. In fact, they might not even resemble a line very great at all, and that's part of what the regression analysis will tell us. So we want to write the linear regression. So Desmos can do that for us. What we do is we'll go into the second block, and we need to type in the equation that I had written right here in step 3. So I need to type in y1. Now, to make the subscript a 1, you just type a 1 behind the y. And then I need to do the little squiggly. It's a little easier to find on the keyboard if you're using a computer, but if you're using the function calculator, you can find it as well. So I do the little squiggly there, and we go M, and then X1, so X followed by a 1, and then plus B. All right? And so what it gives us is it makes a line for that data that is supposed to represent that data. Now we see that that line didn't do a very good job of representing that data. However, that was what the regression analysis gave us, and so that's what we're going to use. So it wants us to round all those coefficients to the nearest 100th. So the nearest 100th for these coefficients. So my coefficients are the M and the B. So M in this case is going to be equal to 0.22. So 0.22. 0.22, and B, nearest 102nd decimal place, would be 57.82. And so our equation here for the regression would be y equals 0.22x plus 57.82. Now this regression equation actually does a very poor job of representing the data. The way we know it does a poor job is by looking at the r squared number or the r number. The correlation is pretty weak. It's 0.2. The correlation number, the strength of the relationship, I guess in terms from a linear standpoint, goes closer to 1 or -1 to be stronger, but that analysis is for later down the road when we get into statistics. So they want us to use this equation to estimate the homework grade. Well, homework was X when the student has a test grade of 57. So when y equals 57, I want to find X. They want us to use that equation. Well, since we have Desmos pulled up, let's do that. So I'm going to delete these two. I'm going to click the X, and I'm going to type in my equation of y equals 0.22x plus 57.82. And then they want to know, when does y equal 57? Well, type y equals 57. And then you're going to look and say, when do the lines cross? And the lines cross when x is equal to -3.727, which tells me that x here says round to the nearest whole number, x would have to equal -4. Now, we call this kind of problem, we call this a bad question here because in context, understand what the domain is for what x. Domain, if you don't know what that word means, it means the set of possible numbers that you can actually use for your inputs. Now, I'm given an equation here, and that you would think that you could use any number that you wanted to here for x. And we think it would make sense that, hey, as I did more homework, my test grade would get higher than a 57.82. If I did no homework, I would get a 57. But for us to get a grade of 57.82, or excuse me, for us to get a grade of 57, we would actually have to do negative homework. What the heck does it mean to get a negative grade on the homework? We did our math was correct. However, this is a bad problem here. And what that means is, more than likely, is we have an incorrect regression model. And that's something else that you look at later down the road, but the technique to perform the regression is the same. So let's look at a second question, and let's hope that we don't have that problem again. So we have a number of newly reported crime cases in a county in New York State is shown in the table where X represents the number of years since 2006. Y is the number of new cases. We want to write the linear regression equation that represents the set of the data. So let's try this again. And so let's clear everything out. And let's type our table in the Desmos. So we'll go +, table, put in our X numbers. So was it 0 through 5? And then we get our Y's in. So I can click the plus sign so that way I can see the points on the graph. Now let's do the regression and let's see how good the regression curve is, linear regression. So y1, well, squigglies, approximately m times x1 plus b. All right, and now I look at the graph and already visually, this looks so much better than the one we had before. So the graph that we had before wasn't very close to any of the points, and this one's actually very close to some points. And so we're going to have a much better fit from a regression standpoint in terms of our predictions. And so our equation here that we could write would be y equals, and instead of mx plus b, m is negative 42.5143. Says round to the nearest tenth. So negative 42.5x. And then plus b, rounded to the nearest tenth, would be 789.6. And now we want to use that to help us find something. So find the projected number of cases for 2014, rounded to the nearest whole number. Well, X is the number of years since 2006. So in 2014 is how many years since 2006? 8 years. So I'm going to take my regression equation and I'm going to find y when I put in 8 for the x's. Now, if you don't have a calculator, Desmos can actually be a calculator for you. I can go negative 42.5 times 8 plus 789.6. Oh, I forgot my decimal. 0.6. And it tells me 449.6 for rounding to the nearest whole number. 450 is our answer.